when we talk about plasmas and things evolving later in the universe, there's a process called recombination where something becomes neutral again after having been reionized. But anyway, it's called recombination, but it's this first moment when neutral atoms are able to form. And so that recombination era, that moment when the first neutral atoms form, that begins what we call the dark ages of the cosmos.
Okay.
And the reason it's called the dark ages is because now the primordial plasma has cooled down, but there's no stars yet. The universe is just hydrogen gas, mostly with a little bit of helium in it. And it's just cooling. It's just gas cooling down, and the universe is expanding. And at the same time, gravity is still pulling together clouds, right? So you have these clouds of cold gas, and those clouds are starting to condense. So the Dark Ages goes on for a while.
Wait, like 2 seconds or
no.
like 10 years?
No, like millions and millions of years.
Oh, great.
Yeah.
Okay.
Yeah.
Hey, we cannot have 10 to the negative 35 seconds and then like 10 to the negative 15 seconds being a while and then have like several million years be a while.
This is the thing, right? Like the time scales get weird, right? Because you count it based on how much is happening. And you can have millions of years of cold hydrogen gas, and not a lot is happening in that cold hydrogen gas.
This is great for us, Katie, because suddenly it's looking like we can get through this season. I'm starting to believe in us. We just skipped way ahead.
Yes, exactly. Yes.
All right. So we've got these millions of years where there are some neutral atoms, but it's just clouds of gas slowly clumping together, slowly getting colder.
Yeah, exactly. So this is the cosmic dark ages, and the physics of it is very simple. It's there. You can write down equations for gas cooling, and it's just doing that. But over time, because we had these little variations in density, some of the clouds of gas start to get a little bit more dense than other clouds of gas. And so...
Whoa. If we'd never had these little variations in density, if our observable universe had been entirely uniform, there never would have been stars and galaxies?
I don't know that they're never... Well, you would still have fluctuations just based on the random movement of particles.
Oh.
So eventually something would happen, but it would happen differently and would take a lot longer.
Okay. That's helpful and a little mind-blowing.
Yeah.
Okay. All right. So we're only here in this current state because of those early quantum fluctuations that came along with inflation.
Yes. Yeah.
Otherwise, I wouldn't be here.
Yeah. Yeah. This is why there is structure in the universe in the way that we know it.
Great.
Yeah.
Okay.
Yeah.
I'm gonna not panic. I'm just gonna listen.
Okay.
That was a clip from The Universe, a new limited series podcast from Crash Course where Dr. Katie Mack, a theoretical astrophysicist, walks me through the entire history of the universe, including the parts that haven't been written yet. It's available now both on the Crash Course YouTube channel and wherever you get your podcasts.